Okay, this is Geometry 7.1, the Pythagorean Theorem and its converse. So let's jump right into the Pythagorean Theorem, which states that if you have a right triangle, then the sum of the squares of the sides of the triangle are equal to the square of the hypotenuse. So that's kind of a mouthful, but in other words, a squared plus b squared is equal to c squared. All right, and the A and the B don't really matter, but C has to be the hypotenuse, okay? And the hypotenuse will always be the longest side, and it will always be the side that is across from the right angle, okay? All right, so now we have some Pythagorean triples. Pythagorean triple is a set of numbers that satisfy the Pythagorean theorem, and the biggest number is always going to be the hypotenuse. So let's write this down. Some common Pythagorean triples would be 3, 4, and 5, 5, 12, and 13, 8, 15, and 17, and 7, 24, and 25. Okay? So again, the biggest number will always be the hypotenuse. So let's write that down. The biggest number is the hypotenuse. Right, so my hypotenuse here would be 5. For this triangle, would be 13, 17, and 25. Okay, so let's do some solving here. So let's take a look at these two right triangles here. Oop, I didn't put the box on this one. Got to have that. Okay, so there's two different ways to solve using the Pythagorean theorem. We can round to the nearest tenth, or we can leave it in the simplest radical form. Technically, leaving in the simplest radical form is more of an exact answer. So rounding is going to give you an approximate answer, but if you keep it in the simplest radical form, that is going to be a more precise answer. Okay, so let's give this a shot. So first one here, like I said, which leg you have as the A and the B doesn't really matter, but the hypotenuse has to be the C. Okay, so let's put this into our equations. We have A is x squared plus B, which we know is 9.4 squared, is equal to 14 squared. Okay, so now we can just go over to our calculator. 9.4 squared, you can hit this x squared button, and we get 88.36. So x squared plus 88.36 is equal to, we'll do the same thing for 14. 14 squared is 196. All right, so I need to solve for x here. So I want to isolate x. So I'm going to subtract 188.36. Need to get a smaller marker here. There we go. Subtract 188.6 on both sides. All right, and I'm left with x squared is equal to 107.6. And now remember, we always do the opposite to solve equations. So if I have x squared, doing the opposite would be to take the square root. So the square root of x squared is x. If I do it to one side, I have to do it to the other side. So I take the square root of 107.6. So again, let me pull up my calculator here, clear this out. The square root symbol on your calculator is the secondary function. You can see it here in green. So to access the secondary function, we want to hit the second key and the x squared key. All right, and you see that little square root symbol. Now you can just type in 107.6, press enter, and you'll get the decimal equivalent. So I got I got 10.373. So I'm going to just round this to the nearest tenth and call this 10.4. Okay, so that would be rounding to the nearest tenth. For the second, we're going to leave in simplest radical form. So again, the a and the b doesn't matter. Maybe I'll make the number the a this time. So I'll do 8 squared plus x squared is equal to 12 squared. Because remember, the hypotenuse is across from the right angle, so that leg needs to be the hypotenuse. Okay, and now we can just square these out. 8 squared is 64, just 8 times 8. 12 squared is 144. And now we want to get the x squared by itself, so I subtract 64 on both sides. And I'm left with 80 on the right side. Drop down the x squared, and now I take the square root of both sides. Take the square root of x squared, and I get x. Take the square root of 80, and let's pull up the calculator again. Figure that out. Second key, x squared, get the square root, function, type in 80, and press enter, and we get this answer in the simplest radical form. So this is 4 times the square root of 5. Now, if you are looking for the decimal equivalent and you are given the simplest radical form, you can always get the decimal equivalent by hitting these double arrow keys right here. Okay, if you want to go back, you can get back to the 4 times the square root of 5 by hitting it again. Okay, but we want this answer in simplest radical form, so I'm going to keep 4 times the square root of 5. Look at the converse of the Pythagorean theorem, which states that if a squared plus b squared equals c squared, then the triangle is a right triangle. So let's see what that means. So if we're looking at a triangle and we're not sure if it is a right triangle or not, we can plug it into the Pythagorean theorem and see if they equal each other. Okay, so we know that the c would have to be the longest side, so that would have to be 26. So we're going to do 26 squared is equal to 10 squared plus 24 squared. And we'll square these out. We get 676 is equal to 100 plus 576. 576 plus 100 is 676. So after we do some squaring, we notice that c squared is equal to a squared plus b squared. So yes, this is a right triangle. So I can put that little box here right there. What about the second one? A triangle with the lengths 6, 8, and 11. Again, 11 has to be the c or the hypotenuse. So we can do 11 squared is equal to 6 squared plus 8 squared. And then square them out. 11 squared is 121. 6 squared is 36. 8 squared is 64. Add them up, we get 100. 100 is not equal to 121, so no, this is not a right triangle. Okay, moving on. So now we have some offshoots of the converse to the Pythagorean theorem, which states that if c squared is greater than, that's what that symbol means, if c squared is greater than a squared plus b squared, then the triangle is obtuse. And if c squared is less than a squared plus b squared, then the triangle is acute. All right, so let's move on to the back page here. Let's try these out a little bit. All right, tell whether the triangle is acute, obtuse, or right. So let me draw one of these out real quick. So let's say I have a triangle like this, and we'll say this is 5, 12, and 15. Okay, so let's put them in the Pythagorean theorem. 15 has to be your c because it's the longest leg. So 15 squared is equal to 12 squared plus 5 squared. And let's see, 15 squared is 225 is equal to 144 plus 5 squared is 25. Add these together, we get 169 and 225. Okay, so if we're comparing these, the mouth wants to eat the bigger number. That means 225 is greater than a squared plus b squared. So this triangle is obtuse. Okay, let's look at another triangle with the side lengths of 10, 12, and 15. So the longest leg needs to be the hypotenuse, or the C. So this is going to be 15 squared is equal to 10 squared plus 12 squared. Square them out, we get 225 is equal to 100 plus 144. 100 plus 144 is 244. So we're left with a squared plus b squared is greater than 225. So if this c squared is less than a squared plus b squared, then we have an acute triangle. All right, moving on. We've got a story problem here. Mr. Kelly is 125 feet directly north of Mr. Brust. They both think they are Jedis. Directly to the east of Mr. Kelly, 500 feet away, is Darth Vader. Which Jedi is closer to catching Darth Vader? Okay, so let's definitely draw this out. So we have Mr. Kelly is 125 feet directly north of Mr. Brust. So let's put Mr. Brust here, and directly north will be Mr. Kelly. He's 500 feet, no, 125 feet directly north. And Darth Vader is 500 feet away east of Mr. Kelly. So Vader is right here. And so who is closer? We need to figure out this distance, right? You know that this is 500, this is 125, so we have to figure out what our hypotenuse is here. So let's see. X squared is going to be our C, 125 squared plus 500 squared. And we square these out, add them together, we get x squared is equal to 265,625. And then we take the square root of each, and we're left with x is equal to 515.4. Okay, so it looks like Mr. Kelly is a little bit closer by 15.4 feet. Okay. All right, now you guys try these. I'm going to give you two. All right, how about a triangle with legs 10, 5, and got to figure out the hypotenuse. And number 2, classify the triangle as right, acute, or obtuse. And let's see, we'll call this 6, 8, and 13. Okay, pause the video, give these a shot. Okay, number 1, we're looking for the hypotenuse. Okay, I should have put this square there. Okay, so we know that this is the hypotenuse. We got x squared is equal to 10 squared plus 25 squared. No, it isn't. 5 squared, which is 25 squared. So now square them out. 100 plus 25, add them together. We get 125 is equal to x squared. Let's take the square root key. So let's clear our calculator. We got second key, x squared button, type in 125, press enter. We get 5 times the square root of 5. This one is asking for a radical form, but if we wanted the decimal equivalent, we can hit this double arrow key and get 11.18. We'd call that 11.2. All right, but this one is asking for simplest radical form. So there we go. Hopefully that's what you got. Number 2, classify the triangle as right obtuse or acute. So let's see. 13 squared is equal to 6 squared plus 8 squared. This will probably be able to do this one all in our heads. 13 squared, 169. 6 squared is 36 plus 64. Add them together, that is 100. Looks like 169 is greater than 100, so this is an obtuse triangle.